So, we will assemble these equations, and before we assemble these equations, because I do not want to go back and forth, I will make this diagram one more time. So, when I do the assembly, how many equations will I get? 5 equations, 7 equations will get compressed to 5 equations. So, I will have a K matrix which will be 5 by 5. So, let us say this is the box, we have to fill it in, and my global displacement vector is u1. What is the second displacement? u2, third one u3, u4 and u5. Okay. So, using connectivity matrix I can program the computer to automatically do the assembly, but now when we are developing this connectivity matrix by hand, we will learn a slightly different trick which will give us physical insight into how to get assembled terms of stiffness matrix. So, this is global node 1, 3, 4, 5, 5. So, rows and columns correspond to 5 different nodes, and these are global node numbers 1, 2, 3, 4, 5. Okay. Now, let us look at K11. This is the global stiffness term. This equals, so K11 global node 1 is connected to what elements? It is connected to only the first element. So, it will get contribution only from first element. So, that is equal to K11 from the first element. Okay. Let us look at global node 2. So, K12, so this is equal to K111. Now, look at K12. K12 is the line, so 12 is this line, right, 12 is this line. So, K12 is the stiffness associated between global node 1 and global node 2, it is the cross stiffness, cross stiffness. Both these, so in this thing element 2 is not playing a role in this case. So, K12 is equal to K12 1. Okay. So, this is global node, this is local node, this is global node, this subscript is local node. Okay. It just happens this in this case in K12 global node and local node are same numbers. Okay. Now, let us look at K13. Again global node and local node numbers are same, and the contribution will come only from first element. So, it will be K131. Understood? Now, let us look at K14 for the assembly matrix. This is my global node number and this is again global node. This is capital, this big K, which is the assembled thing. Node 1, this node and node 4, are they physically connected? They are separated by these elements, right? So, they are not physically connected. So, this term will be 0. Okay. If there are two nodes belonging to two different elements, then they are not physically connected. Then the stiffness for them will be 0, cross stiffness. Now, let us look at K15. This is again global node and this is again global node. Is node 1 and node 5? So, this will be 0. Understood? Now, let us look at something more interesting. So, now we want to do K21 for the assembly matrix. This is global node and this is again global node. So, okay. So, this is again, this corresponds to this line and the role of second element is not here. So, I will write it as K211. Okay. Now, look at K22. This is global node and this is also global node because so K22, it will get a contribution from first element and it will also get, because when we look at it, this global node 2 is being shared by element 1 and element 2. So, it will get contributions from two elements. So, it will have two terms. It will have two terms. What are the two terms? The first term will come from the first element, which is equal to K211 plus K122. Oh, I am sorry. So, you will get K221 plus K112. Okay. Understood? Now, let us look at 23, K23. So, K23 corresponds to this line. So, this 23 is these are global nodes. Again, this line 23, you get contributions from, so these are again global nodes, so I will write them in green. You get contributions from both the elements. So, K23 is equal to K, so contribution from the first element, which will be, so first element local nodes are 2 and 3, 1, and in the second element line 23 is same as line 14. So, it is K142. Understood? Next one, K24. So, K24 is K2 and 4. Here the contribution is only from the second element. So, it is K122 and then K25, this is contribution comes only from the second element. So, it is K232. Let us look at the third row. So, I get K311 So K31 is, and then K32 is a line which is common, K32, 3 and 2. So this line is common to nodes 1 and 2, so I will get contributions from both, and this will be K321 from the first element plus K412 from the second element, and then finally, no, not then I have K33 which is related to the third global node itself. Here I am getting contributions from again 2 elements. So here I will get K331 plus K441, sorry 2, and then K34 is K422, K432 is K35, K41 node 4 and node 5, they belong to different elements and not connected at all. So this is 0, this is K212, K242, K222, K232, and then this is again 0, K312, K342, K322 and K332. So this is how I develop the assembly for the stiffness matrix if I have to do by hand, and I can use the B matrix if I want to use my computer to program it. But if I have to use hand for this exam, this course, you may be asked to develop a stiffness matrix for 2 or 3 elements touching each other. In that case, using this thinking, you can develop specific terms. So this is my K matrix, and that equals the force vector. So this is F11, this is F21 plus F21, third one is F31 plus F42, fourth one is F22, and fifth one is F32, right. And then the Q vector will be Q11, Q21 plus Q12, Q31 plus Q42, Q22 and Q32. Okay. Now, so this, excuse me, this is same as F1, this is same as F2, this is same as F3, this is same as F4, this is same as F5. Okay. And in last couple of classes, we had said that the Q's, when they are added up, right, because of a common boundary, their sum becomes, when we add up Q's, because these are boundary terms, and when we add up boundary terms from adjacent elements, their sum becomes 0. So this will be 0. So I do not have to compute even these Q12 and Q22, right. This will again be 0 because of equilibrium, force balance, and these Q's, and this will be global Q1, global Q2, oh I am sorry, this is global Q4 and this is Q5. So if I have just 2 elements, total number of unknowns is U1, U2, U3, U4, U5, and then what? Q1, Q4 and Q5, 8 things, unknowns are there. So I have to know conditions on the boundary. So either I know Q's or I know 3 U's, then I can solve these equations. Okay. So, that is what it boils down to. So, so out of these 8 unknowns, 5 U's and 3 Q's, either I have to know some 3 of these values through boundary conditions. Once I know those, then I can eliminate specific equations and I can solve for the remaining unknowns. So, this is how it works out. We will do one more example and we will actually write down stiffness terms for another example. So, let us look at another set of elements. So, this is element 1, 2, 3 and 4, and the local nodes are 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 1, 2, 3, and the global nodes are 1, 2, 3, 4, 5, 6, 7. So, these are so the first question is that if I have to develop a B matrix for this, how many rows this matrix is going to have if I have to develop a B matrix? It will have 4 rows because there are total number of 4 elements. Okay. So, it will have row 1, row 2, row 3 and row 4. And how many columns it is going to have? 4, because the maximum number of elements in maximum number of nodes in any element is 4. There are some elements which have 3 nodes, there are some elements which have 4 nodes, but maximum number of nodes is 4. So, it will have, so in this case it will be a 4 by 4 matrix, but the B matrix can be of any order, right, can be of any order. So, now with that understanding, so this is corresponding to first local node, second local node, third local node and fourth local node. Okay. Now, what are the entries in the first row? Row 1, what are the entries? It will be 1, 2, 4 and 3. Agreed? Because the first local node is same as its number is 1, global number is 1, second local node's global number is 2, third local node's global number is 4 and fourth local node's global number is 3. Okay. Understood? Second one is 4. So, this is my second element. So, it will be 4, 5 and 3 and there will be x here. Third row, it will be 4, 7 and 5, another x here, and the last one will be 4, 6 and 7 x here. Understood? So, with this we will just write down some specific stiffness matrix terms. So, suppose we will do 2 or 3 examples and then we will move on. Suppose I have to write down what is the value of global. So, this is my global 4 4. What this is equal to. So, first thing is how many terms it will have. this global, so this is global node number 4 and this is also global node number 4. Node number 4 is being shared by 4 different elements. So, it will have contributions from 4 different elements. So, it will have 4 different individual terms. So, the first contribution from first element will be 331. From the second element, what will be the contribution? 1 1. From the third element, contribution will be 1 1. From the fourth element, contribution will be 1 1. Understood? We will do 1 or 2 more examples so that we become comfortable, because then when you look at any complex mesh, you can very quickly add up just by looking at the picture. K 4 5. K 4 5. What do we see here? K 4 5. So, 4 5 is a line and that is being shared by elements 2 and 3. So, it will have how many terms? 2 terms. So, the first contribution will come from element 2 and from element 2 it will be 1 2. From the second element, what is the second element number? 3. The term will be 1 3. Understood? One more example and then we will move on. K 7 7. K 7 7. So, this 7th node, global node, is being shared by 2 elements, element 3 and element 4, right. So, it will have a contribution from third element plus a contribution from fourth element. The contribution from third element will be 2 2 and contribution from fourth element will be 3 3. Last thing, what is K 6 3? Sixth node and third node, they do not belong to the same element. So, they are not, because they are not physically connected, this number is going to be 0. K 7 1, same thing, it will be 0. Okay. So, using this thought process, by looking at the picture and how things are connected, you can develop expressions for K matrix as well as F and Q vectors, and if you have to develop equations by hand using this approach, you can write down the equations very quickly. But it is important that, so while you are doing it, it is important that you clearly label out global nodes and local nodes very clearly and do not get confused between those two, otherwise you may end up writing incorrect expressions. So, this completes our lecture for today. We will continue this discussion tomorrow, which will be the third day, and what we will do is we will quickly solve a problem for heat transfer, and once that is done we will move on to some other topics. So, thank you very much and have a great day. Bye.